Good morning and Jai Guru to all. So today we are going to start with the continuation of the first topic, history and features of C++. In that we saw features of C++, and the second subtopic which we are going to see today is basic concept of C++. So that is the basic concept of OOPS. So in this basic concept of OOPS, we have 5 definitions. First one is data abstraction. And second topic is data encapsulation. And third topic is inheritance. And the fourth one is polymorphism. So these are all the 4 things which you have to remember when the topic comes with basic concept of OOPS. So we'll see one by one by giving a real-time example. I'll tell you what is data abstraction, what is data encapsulation, what is inheritance, and what is polymorphism. And finally, the next topic, the third one which I'll be having is modularity. So these things we have to do it. The second subtopic is basic concept of OOPS, and third subtopic is modularity. So we will see all these 5 definitions with the examples now. The first example thing which I am going to see is data abstraction. First I will tell you with the real-time example, then we can proceed with the definition part. The example which I am going to teach or tell you is take a switch for switching on the fans and light, right? So when I switch on the switch, what happened? The light is on. When I off it, the light will be getting off. So what we are doing, I don't know what is happening inside the mechanism which is doing inside the switch. How it is getting on and how it is getting off, it's not mandatory to know. To switch on the fan, if you want to switch on the fan, I have to go to that particular place, I have to switch on the switch, then the fan will start running. So what are the things which is hide inside, it's not mandatory to know. The next example is to drive a car, or to drive a motorcycle, to drive a car, what is the main thing which you need to know is driving. So you don't need to bother about what is the engine CC and what is happening inside the mechanism part. How I'm just pressing the accelerator, how the car is moving. You don't need to bother about anything, how the mechanism is happening inside. So what we are doing, we are hiding the entire thing inside, and we are just, if you know driving, we can drive a car. If you know which switches for the fan, I will be switching on that switch and the fan will be running. So this is the main thing which I will be using it for data abstraction. The main definition for data abstraction is, so hiding the essential, hiding the features, essential features like background details or hiding the essential features is a main keyword. So I have to hide all the features that is happening in there. So data abstraction is nothing but hiding the essential features, and then no need to bother about what is happening inside the background and remaining stuff. The example which I told you was, one is switch, or you can take it as message. When I'm passing some message, what happened? When I type some message from my phone, it will be traveling to the receiver side and it will be sending the message. So you should no need to know what is happening, how the message is traveled into the receiver side. You don't need to know about that. The main thing which you know need to, you should know how to type the message. After that, you have to take the selection. You have to select the contacts who you are going to which contact you are going to send the message. So when I click the send, then automatically the message will be sent. You don't need to bother about what is happening. When I am sending the message to the receiver, what is happening in between that, you don't need to worry about. That is hiding the essential function without including any background details. It's called data abstraction. Second one is encapsulation. Second one is data encapsulation. So encapsulation, the example which I am going to teach you was, we can take school admin, the real-time real-time example which I am going to tell you is school admin. In school, if you take a school, we have different departments like science, maths, physics, chemistry, and science it will comes in the physics and chemistry. So accounts and English, Tamil, like that. We have different types of things, and accounts people we have admin and then non-working staff, teaching staff, like that. So many departments will be there. So what we are doing, we are combining all this department to one thing and we call it as a school. So the definition of encapsulation is a wrapping up of data, and function into single unit. Wrapping up of data and function into single unit, we call it as data encapsulation. The example which I told you was school, or you can take a company like a car manufacturing company. We have production people there, we have technical people, we have assembly people, we have manufacturing people, and we have marketing people, we have accounts people. So all together we will be combining into one thing called company. It can be a Renault, it can be a Hyundai or something. So the main thing is the wrapping up of data and function into single unit, we call it as data encapsulation. The third one is inheritance. So inheritance is nothing but, first I'll tell you the definition, then I'll tell you the real-time example. So inheriting the properties of one class to another class. So inheriting the properties of one class to another class, or inheriting the properties of or behavior. So properties and or behavior of one class to another class. The example which I am going to teach you was, suppose you can see we have mammals, right? Mammals, take an example as mammals. In mammals I can take dog, I can take cat. So one thing can be can see it in day and night also, and one animal can see it in day and night also. Some animals they can't able to see it in the night vision. So like they'll be having an inheritance of one class, it will be having the properties. So like mammals, if we take cat and dog, so cat, no, we can see it in the night also, and dog, I think dog cannot be seen in the night. So only cat can see in the night, and then so that we will be inheriting a class from one class to another class. Here dog is one class and cat is one class. So it will be inheriting the properties or behavior of dog to the cat. So that is called inheritance. Or for the simple example which can take us. So for example, if my grandfather is there and my grandfather some quality will be inherited to my father. From the father, he will be having the same quantity or what are things we have, that is our properties of behavior. I think you will be inheriting it. So you will be inheriting from one class to another like this. So I will be inheriting from me. It will be going back to the next person who is inheriting, that is the son. So certain behaviors or properties which I have, it will be having with the son also. So that is what inheritance. The next one which I am going to see is the fourth one is polymorphism. Polymorphism is nothing but ability of processing in more than one way. The ability of processing in more than one way is called polymorphism. That's the definition of polymorphism. The example is, suppose take shape, right? In shape we can have circle, we can have triangle, or we can have rectangle, right? So circle, triangle and rectangle, it's a different shape. But if I am asking you to find the area of circle, I will be using area. If I am asking you to find the triangle area, I can find triangle area. If I'm asking to find the shape of rectangle area, I can use area. So you can see the area is the only one function I'll be using for different shapes. Here the area will act as a polymorphism. The ability of processing in more than one way. So area, I'm finding area of circle, I'm finding area of triangle, I'm finding area of rectangle. So I'll be using the same area, I'll be finding with three different shapes. One is circle, one is triangle, and one is rectangle. The ability of processing in more than one way, we call it as polymorphism. So till this, the basic concept of OOPS will get over. Then we can proceed with modularity. Modularity is nothing but it's a combination of cohesive and loosely coupled models. What is cohesive and loosely coupled models? For example, if you are taking a thing called music system, right? If I want to take simple examples, music system, what are the things we'll be having in the music system is, I'll be having a combination of cohesive and loosely coupled models. The model is nothing but it's a small individual parts which I'll be attaching to perform to finish a product as music system. So what are things we have? We can have speakers, and we can have CD disc, and we can have radio, and then we can have cassette player also. But nowadays cassette players are not there, but earlier days we have cassette player. So all this combined together will produce as a music system. So each and everything we call it as a model. It can be a cohesive and loosely coupled models. Here the cassette player, I'll be creating a cassette player thing and I'll be attaching it. And two speakers will be attached, and then I'll be having a CD player in the top. And then radio I can give it in the bottom. So the entire thing, a combination of all these things, models will be combined together, and then finally it will be making as a product as music system. So this is called modularity. A combination of cohesive and loosely coupled models, we call it as modularity. The example is music system. So all these loosely coupled models will be combined together and form as a music system. So this is the explanation of modularity, and the video which before we saw was basic concept of OOPS. Alright, so thank you.